Chapter 2.6 is on the combination of functions and composite functions. Here are our objectives. I'll let you read through them. Let's first start by finding a function's domain. So if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by 0 and real numbers that result in the square root of a negative number. So basically what it's saying is, if you have a function and it has a denominator, you must be careful of values of x that will cause you to divide by 0. And if you have a function with a square root, you must be careful of values of x that will cause you to have a negative number in your square root. Otherwise, the function is going to be the set of all real numbers as long as it doesn't model data or verbal conditions. Now let's talk about the algebra of functions. We can add, subtract, multiply, and divide functions like we normally do. They follow the same properties of addition, subtraction, multiplication, and division we learned before. Let's go in our books to page 297, and we're going to start by looking at problem number 9. The instructions say find the domain of each function. So f of x equals 1 over x plus 7 plus 3 divided by x minus 9. And we must find a domain of this function. So notice that we have denominators. So we do not want to divide by 0. So the first thing you want to do is set the denominator not equal to 0. So set your denominator not equal to 0. So we have x plus 7 does not equal 0, and we have x minus 9 does not equal 0. Then step 2 would be to solve for x. So solve for x, and we say x cannot equal negative 7 and x cannot equal 9. So your domain consists of all real numbers as long as x is not equal to negative 7 and x is not equal to 9. If we wanted to write an interval notation, let's first start with a number line. Put your negative 7 and 9 on a number line. And since it says does not equal to, we're going to open a parentheses to the left and to the right on the negative 7 as well as on the 9. And then you will shade everything else in between and to the left and to the right. Then out here on the far right is infinity, and on the far left is negative infinity. So the interval answer would be from negative infinity to negative 7, union negative 7 to 9, union 9 to infinity. So this is your solution representation of your domain. This is the graph representation of your domain, and here's the interval. All right, now let's look at number 17. Still, we're finding the domain. This time we're dealing with f of x equals the square root of x minus 3. So this time we have a square root, and we want to avoid having negatives in our square root. So we must take the expression inside the square root, the x minus 3. So you want to set your expression. So set the expression greater than or equal to 0. And then step 2 would be to solve for x. So x minus 3 is greater than or equal to 0, which means x is greater than or equal to 3. So the domain consists of all x's that are greater than or equal to 3. If we wanted an interval, we're going to start with a number line, put 3 on the number line. Since it's greater than or equal, I'm going to use a bracket this time. And I'm going to face to the right because it's greater than and shade all of this. This goes out towards infinity. So the interval notation would be bracket 3, comma, infinity. And then number 27. This time we have a function of g of x is equal to the square root of x minus 2 divided by x minus 5. This time we have a square root as well as a denominator. So with the denominator, remember we set it not equal to 0. So x minus 5 is not equal to 0. And with the square root, we set the expression greater than or equal to 0. So x minus 2 is greater than or equal to 0. And then we solve. So x does not equal 5, and x is greater than or equal to 2. So our domain consists of all x's that are greater than or equal to 2, but not equal to 5. So let's draw our number line. Here's the 2, here's the 5. It says greater than or equal to 2, so it's going to be a bracket, and it's going to be opening to the right. And it says not equal to 5, so on 5 we have parentheses, one opening to the left and one opening to the right. And we're going to shade all of this up here. And to the far right we have infinity. So our domain consists of bracket 2, comma, 5, union 5, comma, infinity. Alright, so now let's talk about the composition of functions. The composition of the function f with g is denoted by f of g and is defined by the equation defined by the equation fog of f of x. I call this fog. That's what's confusing me. I denote this just as calling it as I see it. He is called fog. It's the same as saying f of g of x. So notice here that the g of x is inside of f. So it basically means plug g of x into f. So everywhere you see an x inside of f, you're going to put the entire g of x. And then the domain of the composite function fog is a set of all x such that x is in the domain of g and g of x is in the domain of f. Other than fog, we also have golf. And golf is written as g of f of x. So it's g of f of x. And notice this time, f of x is inside of g. So you plug f of x into g. Now, what values do we exclude from the domain? If x is not in the domain of g, it must not be in the domain of fog. So let's examine that further. So fog is the same as saying f of g of x. F of g of x. Well, if x is not in the domain of g, meaning he does not work for g, how will he work for f? Therefore, he cannot be in fog. So if x is not in the domain of g, he's not in fog. Then any x for which g of x is not in the domain of f, let's read that again. Any x for which g of x is not in the domain of f must not be in the domain of fog. So that's saying the same thing again. If it doesn't work for g, it's not going to work for f. Or fog, my fellow. Now let's practice some problems because it's very confusing when you just hear words. Let's look at them. Let's start by looking at number 55. We're on page 298 now. And it says find, and we have 4 parts. Part A says find fog, and then golf, and then fog of 2, and golf of 2. We're going to use part A, B, and C for number 55. So f of x is equal to 4x minus 3, and g of x is equal to 5x squared minus 2. And part A says find fog. So fog is the same as saying f of g of x. F of g of x. So you're going to take g and plug it into f. So we have 4. So first thing you look at is find the f of x. So here he is, 4. And instead of writing x, you plug the entire g into it. So you get 5x squared minus 2 minus the 3. Don't forget to subtract the 3. He's still part of it. And this breaks down to 20x squared minus 11. So fog is equal to 20x squared minus 11. And then part B says find golf, g of f of x. So g of f of x. So this time you're going to plug f into g. So g is 5 times, and instead of putting the x, you're going to put all of f. So this becomes 4x minus 3, whole thing squared, minus 2. And then you get to simplify it out, and you should get 80x squared minus 122. Hold on for a second. I'm working this out as well as you, so you work it out in your papers, and hopefully we can match up together. So that's 16. So this is 16x squared minus 24x, and then of course plus 9. And that would make that negative 120x plus 43. And that appears correct. Okay, so hopefully you got the same thing I have, and hopefully I have the correct answer. I trust I do. For some odd reason, I just have to check over myself. Alright, so that gives us golf. So then part C says, find fog of 2. So you have 2 options when completing this problem. So it says, find fog of 2. What you could do, if you trusted your answer in part A, you can just plug the 2 into it. So everywhere you see an X here, you would just plug in 2. But if you wanted to do it another way, just in case, let's say you made a mistake in part A, you would work this out to be f of g of 2. Because remember, fog of 2 is the same as saying f of g of 2. So the first thing you need to do is find g of 2. So we're going to work it out this way, and then we'll verify that we get the same answer here. So this will become g of 2 is going to be 5 times 2 squared minus 2, which should be 18. So now this just turned into f of 18. So instead of writing g of 2, now you're writing 18, which means f of 18 is going to be 4 times 18 minus 3, which should be 69. So fog of 2 should be 69. So let's check it. Fog of 2 is equal to 20 times 2 squared minus 11, which is 69. So they match up. Alright, let's continue. Let's look at number 71. Now it wants us to find fog as well as the domain of fog. So number 71. F of x is equal to the square root of x, and g of x is equal to x minus 2. Part A says find fog. So fog is just saying f of g of x. F of g of x. So you're going to take g and plug it into f. So that just becomes the square root of x minus 2. And then part B says find the domain of fog. So to find the domain of fog, since g went into f, the first thing you need to do is find the domain of g. Find the domain of g of x. Well, g of x was just x minus 2. It does not have a denominator. There are no square roots. Therefore, its domain is all real numbers. So I'm going to say all real numbers for its domain. Therefore, there's no restrictions on my fog. So then the second step would be to find the domain of fog, f of g of x. And if there was a restriction, I wouldn't include him in the domain of fog. But since there aren't any, I can just keep going. So fog was written as the square root of x minus 2. And since I have a square root, and we do not like taking square roots of negative numbers, we're going to set x minus 2 greater than or equal to 0 and solve for x. So we have x is greater or equal to 2. So then its domain would be from 2 to infinity. So the domain of fog is just 2 to infinity. Alright, now let's work on number 81. This time it says, express the given function h as a composition of two functions f and g, so that h of x is equal to f of g of x. So this time they gave me h of x to be 1 over 2x minus 3. And I must find functions f of x and g of x such that h of x is equal to fog, which is just f of g of x. So basically now we are working backwards. They have given me my composition function, and I must come up with the two puzzle pieces to make it. And the clue is that it needs to match fog. Well, fog is saying g into f. G into f. And since you are working backwards, you start with finding f. So f has to mirror this function. And this function says 1 over 2x minus 3. So let x be 1 over x. That's a good example. Let x be 1 over x. It just has to mirror the actual behavior of the composition function. So 1 over x. And then since g goes into f, we need to pick g so that it works out to be 1 over 2x minus 3. So let g be 2x minus 3. And you can verify if you do fog, you get this h of x. Now there's many possibilities that you can pick for f and g, right? Let's pick another possibility. What about this time we said f of x was equal to x? So we pick f of x, which means g of x would have to be what? 1 over 2x minus 3. G of x, the entire thing, must go into f to get us this result. Alright, this concludes the video for chapter 2.6. Let me know if you have any questions.